Hello, I'm Sumesh Kumar. Today I'm going to present you the project named Financial Transaction Monitoring System. So the objective of the project is to monitor and analyze financial transactions for fraud detection. So basically, in this project, I have used Python, then Apache Spark, then Azure Delta Lake Storage, Azure Databricks, Azure Data Factory for the automation, and also the Azure DevOps for the CI/CD part. And this setups facilitates streamlined data handling and ensures scalability for the larger data sets. So basically, in this project, I will run the data in the medallion architecture, which consists of three layers: bronze, silver, and gold. So, so the bronze layer is like ingest raw transaction data from Azure storage, serving as the foundational layer. Then silver layer applies a cleaning process in Databricks, which include duplicate removal, normalization of numeric fields, and the gold data to calculate a fraud scores using a regression model and identifies flag transition for the further investigation. And so to start the project, uh, here I have created one storage browser named Somesh1234, and in that I have created one blob container called raw data, and there I have put that data set here, and from here I will ingest the data to the bronze layer of the medallion architecture through ADF. In ADF, I have created first I created this copy data. This copy data basically transfers the data from one source to another source. So one in this first I have created the linked services. So linked services are basically the but to link a particular Databricks or blob storage to other services of the Azure. So I have created Azure Blob Storage. Here you can see it takes the storage browser, its account key. Uh, this we can take from here, and we can test the connection also. If the connection is proper, wait. Yeah, see, if the connection is proper, then it is connected. So we can create one link point from the source where the data is stored, and one link point to the blob container where we have to transfer the data. So I have created two storages, and then we go back to this copy data. Here you can see on source we will select the uh, so in copy data you can see we will select the link service, then the path where the data is stored, and similarly in the sync we will choose the destination where we will choose the link service in from which it is from with to the storage where it is we have to move it. So we have to move it to the bronze layer, and we will connect those, and then we will run the this copy data. So once we will run this copy data, so we can see it will go to the bronze layer. One that will show you storage financial. I have created this for the to project specific. In this, all the three containers are there: uh, bronze, silver, and gold. So you can see after running that, our data has come to the bronze layer. So uh, in the bronze layer, now we will connect this storage in the Databricks, and So this is the interface of Azure Databricks. Here, all the three notebooks are present under a repo. I will come to the repo part when I will discuss about the Azure DevOps. So to run each of the notebook, first you have to create a cluster which is present under this compute section. The cluster is basically nothing but like it will give our computer or system to a virtual machine through an instance and all to run the notebook to the cloud. So once I will open this notebook, this all the three notebooks are based on the Medallion architecture. So I have also already said previously. So bronze layer is to in the ingest raw transaction data from the Azure storage. So first it is the we are mounting the storage. So this is the source of the storage. Then this is the mount point, and this one is the key. This particular thing is the key of that blob storage. We can go to the key from it. I will show you. We can access this key from this security networking, and here we can find this access keys. Here you can go and copy this key uh, in this part, and when you run it, it will show the output true. And after it means that our storage got mounted to this notebook, and then this particular code will tell us the path of the notebook. Then here we have read the path in the CSV form, and it is shown here. Then here we are printing the schema. Schema basically tells us what type, like what is the structure of the table, like what other rows are there, like type, what is its step, type, amount, is all the rows. What are the rows? Then df dot show, it will show the first few rows of the table. Then df dot count, like how many numbers of rows are there. Then it describes the df dot describe dot show its shows the statistics of the table, like maximum, minimum, mean, median, and all. And this is the column. These are the head. Then df dot collect, and df we are grouping the amount. So that is the total amount. So this is about the bronze layer. Then I will go to silver layer. Yeah. So this is the silver layer. So as we have taken the data in the bronze layer, and there we have to know about the data, like what type of raw data is present in there. So we have again read the data from the bronze layer, and here we will actually in the silver layer we will do the transformation part, like cleaning the data, then normalizing it, and all that stuff, like removing the duplicates, all that stuff we will do here. So again, like we are like dropping the duplicates here, then we are drop the missing critical fields. Uh, then here we are like cleaning, we are doing more cleaning on the data set, like old balance is, and on the old balance we are creating one column named old balance destination and new balance destination, where name destination start with M and the value are 00. Then filling the values for a specific column. Then all these stuffs are then normalizing the data, all and all this and also creating a new column if there is a mismatch and all. Then printing the table here, and again we after doing the transformation on the data, we again point to the silver layer of the Medallion architecture, which is basically uh, which is basically used to transform the basically used to store the transformed data sets. So we are actually mounting this silver layer. So again we have put the silver layer address, mount point, the key, and all. and we have put this df.clean in a Parquet file in this storage. So you can see it when we run that, the file got stored in the C in the form of Parquet file. Now coming to the last layer, which is the gold layer. Here we will do the model training. Like now the data is transformed. Now it is ready for analysis and model training and all. So yeah. So now like we have stored that previous transformed file in the Parquet form. So here we have read that file and we displayed it. Then here we are showing that is the how many like fraud transaction is there, like how total number of fraud is there or not. So we can see from the pie chart, like is fraud means the legitimate transaction is 99.87 and like 0.13% is the transaction which are like fraud transactions. So coming to the different part, here we are seeing it is a like stacked bar graph. It is like in this bar graph, it will show like how many transactions of each type, such as cash out and payment, etc., are fraud versus non-fraud. So like zero is non-fraud and orange is non-fraud. Here you can see it is very little, like 4,000 something. Here also it is like 4,000. So the bars are stacked with different colors representing is fraud, and the length of the bar for each type indicates the total number of transactions. The color separation will help in understanding which transaction types have a higher portion of fraud cases. So you can see that like cash out has the higher portion of fraud compared as payment. So now next is this is the box plot. So in this box plot, it will visualize the distribution of transaction amount for both like fraud and non-fraud transactions. The chart will display the range of transaction amount from minimal to max, as well as the median and quarterlies, giving a clear view of spread of the values of each category. And again, we are seeing like how many mismatches there and all. So this chart like helps to identify is there any relationship between balance and the mismatch and the fraud transaction, between balance mismatch and the fraud transaction. Stacked bar chart will show the total number of transactions where there is a mismatch in the balance, and the color coding will separate the fraud from non-fraud ones. Then the next one is like the this is the like highest total transaction values for each case, like cash in, cash out, debit, payment, transfer. Each bar will represent a transaction type, and its height will show the total transaction amount for that type. So these are the like different visualizations we have done in the data set. Now this bar graph tells like if there is a mismatch, indicate there is a balance mismatch, and this chart will focus on the fraud transaction where fraud is one. Okay, and it will group fraud transaction by type and show how many of them have a balance mismatch. The bar will be stacked with color representing whether a balance mismatch exists or not. Like in cash out, there are like false means there is a mismatch, and true means there is no mismatch. And now we have calculated the correlation between different fields, like is fraud and amount. You can see it's like correlated with each other, and these threes are very less correlated with each other. Yes. Now, so here we have trained the model in the logistic regression. So we have like assembled the feature, calculated the normalized field, then defining the regression model, then defining the pipeline, and then splitting the into like test and training one. Then we have trained the model and made the predictions. And then we have calculated the AUC. AUC is basically the area under the curve. It evaluates the model using AUC, and higher the AUC indicates better model performance. So we can see we have achieved 0.98 AUC, and there here we and here we can see that filters the predict result to include only transaction classified at the fraud, which means prediction is equal to 1. So we can see the fraud transaction, how many fraud transactions are there. So it's 887. And here are the fraud transactions rows, and total number of fraud transactions is there. And here again we have mounted the gold layer to the code where we have to store the fraud transaction, and we have stored the fraud transaction in the parquet file. So wait, I will show you. Yeah, gold layer. Uh, yeah, we are here. We have stored the file in the Parquet format. So this is all about the Databricks. Now I will tell you how to automate all this process from like ingesting the data to processing the data in the Azure Data Factory. So this is the Azure Data Factory. So basically, previously I told you about the copy data. So on the completion of the copy data, I have connected the three notebooks. Notebook one, which is bronze, notebook two, which is silver, and notebook three, which is gold. So in the bronze notebook, again, I have created one what is a linked service for the Databricks. Here, Databricks will automatically take that Databricks workspace URL, and the access token you can access from here, like going to profile, settings, and here developer. Then from here you can manage the access token and generate a new token. Here you can all see I already generated the pipeline access token, and I have fed here the token. Then you have to give the cluster versions and all. Then you can test connection, and the link service will be created. And after like pulling the notebook from this Databricks, where we can pull the notebook. When you pull the notebook, then you can create the link service which we created previously. And here you can give the path of the notebook. The path is release slash bronze. Why this release is there? Again, I will discuss if in further in the Azure DevOps part. Similarly, for all the notebooks, you go to like connect the link service and define its path, and yeah, that's it. Like, and this tick means validate, means if this particular model will complete, then it will go to this model. Then if this model will gets complete, then it's go to this model. And if this model will gets complete, it will go to this model. After doing all the changes, here publish all option will come. Once you publish all, you can trigger it. You can do two types of trigger. One is scheduled trigger and one is trigger now. So if I click on trigger now and okay, the pipeline will start running. As you can see, it is the monitor tab. Here you can see I have run the previous pipelines. If you click on refresh, see our pipeline one started running. And if you click on it, it will show you the in detail which part is running and all. Mhm. See, the first part is getting in progress. After some time, all the four modules will get completed. So as you can see, whole pipeline got executed, and each part got succeeded, like copy data, then bronze notebook, silver notebook, and gold notebook. So here we can automate the whole process, and like if we want to like do the automation, so that we like if we don't want to do manual trigger, we can also do like edit trigger. From here we can do the schedule triggering like for every 15 minutes. This will like In each 15 minutes, the pipeline will get automatically get triggered, and the data will get ready on the regular, and the analysis will happen in the regular basis. Here also you can see it, refresh it. Yeah, here you can also see it, the pipeline got succeeded. So now we will go for the Azure DevOps part. So as we have already seen the Azure Data Factory, how we have automated the whole process with the help of pipeline. And now our last part is to develop a CI/CD pipeline using Azure DevOps. So DevOps is nothing but development and operations. In a business or any organizations, there are many developers, uh, like uh, like developer one, developer two, developer three, and they are working on a code individually. So, what if they have to put the code in one part, and again they have to use it for the production and also ease those things. So there comes a term known as CI/CD pipelining. It is continuous integration and continuous development. Basically, in that we a developer do some changes or develop a code, and that code will be in the repository, in a Git repository, and then that from that Git repository we push the changes or the code and to the repo, and then from that like there will be three repositories in the Azure DevOps: main, production, and development. So in the development repo, we create a code or we update a code what you have to do from the developer side. Once it is done, so the code will be commit and push to the repo in the development repo, and from there we will run the CI/CD pipeline. So from the development repo, it will go to the main repo, and from main repo, it will go to the production repo. And in the production repo, the final like code will be present. So this process gets automated in the Azure DevOps part. So once this is the home page for Azure DevOps, here you can see you can create a new project. So I have already created our project, uh, name financial transaction monitoring. So once I open it, uh, wait, I think it's yeah. So this is the home page of our project. You can see here many things are there. Summary dashboard, wiki where we can store the notes, boards. We can do the sprint and all here. So here is the repo. So here in the repo we have created three branches, which is uh, development, production, and the main branch is already there. And then here we have created a pipeline. So here two pipelines are present, like main to production, then production to release. So I told you before, like from development it will come to main, from main it will come to production, and production it will go to release folder. In the previous I told you what is release folder. So the release folder is basically the folder where the final code will be kept, and that code will be used for the automation in the Azure Data Factory. So once and here I have created a Git repo, development Git repo, where the developer will make some changes in the code or develop a notebook. So I already made some changes in the code to show you how this pipeline runs. So here you can see three notebooks are there, and here you can see what changes I have done. The red one is the previous code, and the green one is the changes which I have done. Here you have to give some commit message like new changes, any commit message, and you have to just click on commit and push. This will push the code to the development uh, repo. Yeah, you can see that it is put to the branch development, and once you go to the Azure DevOps, here you can see the files, and you can see like we have just updated the development. So here you have to click on the pull request. So see here from development, it will go to the main, and the message is the what message we have typed earlier. We can click on create. After seeing all the things, you can click on complete. It will complete and merge the and it will run the pipeline. See, it is doing the merging the pull request. See, it's got completed. Now you can go to the pipeline and see that main to production pipeline got queued, which means it is about to start. See, it got started. Once you will open this pipeline, can see these are the different parts which will get run to like to to move the code from main to production. And once you click here, the Azure part, you can see the job. The job will give you the detailed analysis what is happening in the pipeline. See production to release. Main to production is still running. After it will get checked, then this pipeline will get started. Yeah, I think almost it's completed. Yeah, it's merges changes from the main branch. Now, yeah, see now both the uh, pipeline got completed, and when you click on this merge to the main line, you can see here, and if you click on jobs, you can see all the things I've done, like initial the job, check out the financial transaction report, then publish pipeline, install Databricks CLI, configure, test Databricks, download pipeline artifacts and all. And you can see here that the file is got view 3 changes. Yeah, you can see here the changes which I did, like see all the 3 files, bronze, gold, and silver. What are the changes I have did? So basically, this is the simple Azure DevOps. Like it, and all to build the pipeline, you have to just click on new pipeline, and there are several options to build a pipeline. Like I have used the Azure Repo Git as I told you earlier. So from here you can do the pipelining, and I created the repository financial monitoring system. You can click on this, then you can create a starter pipeline. It will go to the YML code. There you have to write the configure the pipeline, and it will act accordingly. So this is the Azure DevOps part. Uh, After like continuously running each pipeline, whatever changes will make in this repo in the development branch, it will get updated in this release folder. See in the release folder, all the 3 notebooks got inserted, and after this, see here you can also see the timeline. 19th December 2024. All the three got published, and from here, you can take the notebooks to the ADF for the automation process because this is the final code. So this is all about the project. Uh, so in the conclusion, this project successfully demonstrated the design and implementation of scalable fraudable detection pipeline using the Azure Databricks and the Medallion architecture, and it also capable of logistic regression model, which developed using normalization and calculated features to classify like fraudulent transaction with high accuracy, and also reflects by the strong AUC score, and the final prediction is also stored in the gold layer. So thank you very much.